Our Flet character is currently moving across the screen in one direction. In the game state, we currently only have the Sprite X and the Sprite Y. I'll set up a direction as a string and we'll have it be going to the... I'm also going to set a current frame to try to get the animation going here. And the frame will be, the current frame will be a dictionary with the first is a string and the second will be an int. And we'll be set it to none initially. After the initialization at the top here, which the data class automatically sets up the init, we're going to run a post init, which is from the data class. And we'll use this to set the current frame. We'll set up for all directions, even though we're dealing with just one direction currently. There's only 4 directions in our game. There's left, up, right, down. Set up one more method in here. I'll have to accept the direction as a string, and it will change the direction. And thus update the state. I'm going to create a new folder in here. I'll call the folder control, model view control, and in the control folder, I'll create another file called movement.py. In movement.py, I'll first import the game state, model.game state, import game state. I'll set up the right frames. Right dot. One, right 1, right 2, right 3, which will be our frames for the going right. I'll create a method for updating the sprite, which will receive the game state. And it will return nothing. We'll use match case. So for the case of right, we'll set the current frame. We're going to deconstruct the current frame dictionary. So that's what the two dots mean. And the current frame dictionary will be deconstructed, but we will alter the right. We'll increment it 1, so if it's 0, it'll be 1. Now we will move it within the update sprite. $800 minus 80, which so 80 is the width of the sprite. For all their cases except for write, currently, it's going to just pass it, which means it'll take no action. So the state here is holding the current frame. This is the key, right? So the key is be 0 initially. And then when we move it, we update it to 0 plus 1, and it's going to repeat. Okay, let's explain what this modulo here is doing, right? So the length of the write frames is 3. So we know that this will be something modulo 3. Initially, the write is set to 0. So 0 plus 1 equals 1. So what we're going to end up with is 1 modulo 3, which is equal to 1, right? So 1 divided by 3 would be 0, remainder 1. Next time through the loop, if it's 2 modulo 3, it will be 2. 3 modulo 3 will, of course, be 0. So it's going to go back to 0. Then we'll increment it back to 1, right? And it'll be 2 because it's adding it. So the sequence will be 0, 1, 2, and it'll just keep repeating itself. I'm going to copy this list of frames, and I will reuse it. So I copied it. I'm going to go into the game, and in the game, I'll set up a frames equals, and the key is the dictionary will be the list of frames. Now in this loop, instead of directly updating the state, we're going to call the update sprite that we just created. We just created it here. So this is now handling the movement of it, which is in the control. It's the control portion of MVC. Focus back on the game. Actually, referring back to the game state, we have the current frame, right, which is a dictionary. So we're going to use it. Create a variable for current frame index. And it will be the state of the current frame. And then we're going to pass it state.directional, right, which right now is always going to be right. And now we can get the current frame path from the frames right there. And we'll get the state direction, which is always going to be right currently. And I'll get the current frame index, which is right here. So right now we have the hard-coded for the source of the image. So now we can feed in the image that's being updated within the state. Okay, let's try it again. I'm going to run flet main.py. Oh, nice. She's walking very nicely. Good, good. Congratulations on getting the animation working and setting up the infrastructure in your application for more animation. It'll be much easier now that we've set up all the pieces. Animation takes place at a set of frames. We only have a 3-frame animation for each of the 4 directions. The frames are held in a list of strings that just has the file name or the location of the file. These are just standard PNG files, and they're stored in assets. So we have the name of the file in the list. There's a 3 index or a 3-element list here with the index from 0, 1, or 2. To get the animation going, we simply put the animation frames in a loop. Then we set up a delay between each of the frames. In our case, we're using 0.2 seconds. And then we swap out the name of the file that is being displayed within the container. When the character is going to the right, there is a loop that's using the let use effect, which continually runs and goes 0, 0.2 seconds, wait, 1, 0.2 seconds, wait, 2, and then it's going to flip back to 0. We haven't covered the other types of frames, but when we set up the down frames, all we have to do is swap out the character, the image that's going to the right, which is a string, to the image that's going down. That's how we're going to change the direction in the next video. In the game state, we did add the direction. However, right now, it can only be hard-coded as right because there's no buttons, which we'll cover in the next video. The current frame is a dictionary. So we need to know the direction the character is going, such as in this example, right, and the index of the list for the frame. So this would be, if it's right, we match it up to right, and then it goes 1, and then it goes, after that, there's a separate loop that will go 2. There are 2 pieces of information that we do need to track: the direction the character is going and the image path that we want to show. We're using the image path index here as a way to track and cycle through each of the frames. We're using the Python data class to set up the initial values of the dictionary with something that's built into the data class called post-init. All this does is it runs the bit of code that's within the post-init method. We have another method in the data class to set the direction. So this would be in the game state, and it's a very small method that's used as a setter to set the direction. We created a new folder called control. MVC, which is the simplistic architecture that we are using, stands for model, view, control. And the control is where we have the logic of the game, such as moving the character. We've already set up the view, which basically is how the game looks, and the model, which is the data structure. And in the model, we have the game state. Because the state of the frame is held as a dictionary, because we have write as the key and the value would be the integer number of the index of the frame, we're using a dictionary unpacking. This is standard Python. It's 2 asterisks, and that will unpack the dictionary and allow us to just change one of the elements in the dictionary, and it will create a new dictionary from that. We've also covered the use of the Python modulo, which just takes the remainder. So 0 divided by, in this case, there's 3 frames, is 0, remainder 0. 1 divided by 3 is 0, remainder 1, and then it repeats. Once it gets to 3, it'll go back to 0. In the next video, we're going to cover the flet buttons that we're going to use to control the direction and alter the state of the game with the direction, which will then trigger the rest of the updates on the screen.